Hello. Today we're going to look at seasonal heating on Earth. So we mentioned that the Earth absorbs different amounts of energy per unit area depending on the latitude. And this is because the angle on which the energy from the Sun intersects the surface of the Earth changes with latitude. And because of the tilt of the Earth, during some parts of the year, the northern hemisphere is tilted towards the Sun, so it'll absorb more energy per unit area than the southern hemisphere. And then during other parts of the year, in our winter, the southern hemisphere is tilted towards the Sun, and so there's more energy per unit area being absorbed in the southern hemisphere. So what we're going to do here is we're going to use a tool called NOAA View, which it can be found at www.nnvl.noaa.gov/view, which allows us to graphically visualize data. And what we have here is we have sea surface temperature data, and it's plotted using a color scale. And the color scale you can see here, the very red water indicates 32 degrees centigrade, and the very blue water indicates -2 degrees centigrade. You can see this is the sea surface temperature for this past week, which we're looking at, and you can see it varies with latitude. Why? Well, because there's more energy per unit area being absorbed at low latitudes than high latitudes, so we have a warmer sea surface temperature at lower latitudes than higher latitudes. We could also look at data averaged over months and over years. We would look at how the sea surface temperature changes yearly if we wanted to observe changes in Earth's climate. But to look at the seasonality of heat being absorbed on Earth's surface, we look at a monthly average. Now let's go back and let's start. Let's start at the month of January. This is January 1988, and the equator is right here. And you can see that the southern Atlantic Ocean basin, the sea surface temperatures are warmer than in the northern Atlantic Ocean basin. And why? Because during January, the southern hemisphere is tilted towards the sun, and so there's more energy per unit area being absorbed in the southern hemisphere than the northern hemisphere. But as we see, as we progress through the months, this is February, March, April, May. See what's happening is the southern waters are becoming cooler, northern waters are becoming warmer as we leave the northern hemisphere's winter and enter the northern hemisphere's summer. June, July, and August. Now we can see the complete reversal. Now the northern Atlantic sea surface temperature is warmer than the southern Atlantic sea surface temperature. Why? Because now we're in the northern hemisphere's summer, and the northern hemisphere of the Earth is tilted towards the sun, and so there's more energy per unit area being absorbed in the northern hemisphere. We progress more, we go August to September, October to November. You see in November, it's, in October, it's pretty much the same because we're transitioning. This is fall, and during the fall and spring, most amount of energy per unit area being absorbed is near the equator. This is December, and now we're going to transition to the winter, northern hemisphere winter, southern hemisphere summer. This is January, February, March. We're back to those warm southern hemisphere sea surface temperatures. April, May, and reverse the pattern as we go back into the northern hemisphere's summer. So we can observe this in the Pacific Ocean as well. So this is October, which is very warm northern Pacific water. Let's go in November, transitions so that we have, this is February, very warm southern Pacific sea surface temperatures. March, April, May, June, July. So now we have very warm northern Pacific sea surface temperatures. So we can see this heating pattern all throughout the planet, and it's due to the seasonality of the heat absorption on Earth's surface. And remember, the seasonality is the result of the Earth's axis rotation being tilted. And during some parts of the month, mainly our summer, the Earth's rotation axis is tilted toward the sun, and other parts of the year, our winter, that rotation axis is pointed away from the sun, so the northern hemisphere is pointing away from the sun. Okay, well, that'll do it for right now. Stay tuned for sort of more use of NOAA View in the future as we look at sea surface currents in the next lecture.